Hello everyone. In this video we are going to start with binomial theorem. So what is binomial theorem? Basically binomial theorem is the general form of all the expansions that we do, like a plus b whole square, a plus b whole cube and all. So if we do the expansion for any positive integer value, then that theorem that says about the expansion is called the binomial theorem. Binomial because there are two terms are here. It's a binomial term, that is a plus b, and then we are having the power n, where n is a positive integer. Remember, this n can be negative integer also and even fractions, but those extensions are not there in our syllabus. We are only having this positive integer power. So how we are going to expand it? So as you have seen already that the formula for a plus b square, or the expansion for a plus b square, is a square plus 2ab plus b square. Or if you see it is as a plus b whole cube, then we are having a cube plus 3a square b plus 3ab square plus b cube. So in general, what we see, or you can better say how we can do the same thing for any other power. So the basic thing is that when we are expanding a plus b whole square, we are doing the product a plus b into a plus b. Whole square means we are multiplying twice. In the same way, when we are doing whole cube, we are multiplying the same term thrice. A plus b into a plus b into a plus b. And you can see one thing, that in the expansions, all the terms are of the same power, that is the power here for the expansion. It's 2 here. So in each of the term in the expansion of a plus b whole square is 2, is having the power 2. That a square is a 2 degree term, ab is a 2 degree term, b square is also a 2 degree term. When you are coming to a plus b whole cube, then also we are having the same thing. Each term is having the power 3. A cube, then a square b, it's having total power 3. AB square is having total power 3, and b cube also. So it is evident that when you are expanding a plus b whole to the power n, then the total power of each term in the expansion should be n. So that means if you take the term like a and b and you are giving some power, so it should be the total sum of the power should be n. So if I take any power r here, then the power of a should be n minus r, because then only the total sum of the power should be n. So the terms will be of this kind: a to the power n minus r, b to the power r, or you can say a to the power r, b to the power n minus r. It's the same thing, but we are taking it like this. The terms we are taking like a to the power n minus r, b to the power r. So now the important thing is that how many times these are repeated, means how many times these are occurring. Like you can say in the expansion of a plus b whole cube, that a square b is occurring 3 times, that's why it is 3a square b. So the point is to find the coefficient of this term. So for each term we are having some coefficients, so that coefficient we need to find, and that coefficient is called binomial coefficient. How it is coming, let us see. So when we are expanding, say, a plus b whole to the power n, basically we are doing the product a plus b into a plus b into a plus b, and in this way we are taking the product n times. This is taken n times. So we can say the same thing as this also, that each a plus b is basically a bucket which is containing both the terms a and b. So we are having n such buckets here containing the terms a and b, and if we want to take any of the term of the expansion, like a to the power n minus r, b to the power r. That means we have to take r different b's from these buckets, and then we need to multiply them, so that becomes b to the power r. And this a to the power n minus r means we need to take the remaining n minus r as a. So r b's we are taking from r different buckets, and the remaining n minus r buckets we are taking a. So in how many ways we can take these b's, this r number of b's, in how many ways we can take, this is the question. So obviously we are having n buckets, and from that we are taking r, that means it should be ncr. So when we are taking these b's, this r number of b's in ncr ways, the remaining buckets will be giving us a's, that means n minus r a's. That means after multiplication we are getting a to the power n minus r. So see, there is no requirement of again selecting the a's, because whenever we have selected the b's, from the remaining buckets we are selecting a's. So there is no requirement of selecting these a's differently. So that means we can say that this b to the power r is coming in ncr different ways. That means this term a to the power n minus r, b to the power r will be coming in ncr different ways, and these are coming in ncr different ways means that should be the coefficient of the term, because that many times we are adding this term a to the power n minus r, b to the power r. So we can say that this binomial expansion will contain the term a to the power n minus r, b to the power r ncr times. So this ncr will be our coefficient of this term, and this is the reason that these are called the binomial coefficients. Binomial coefficients. So these are the things. Now you can see that whenever we are saying ncr, we are having a restriction on r, that is 0 less or equals to r less or equals to n. So for each of these values of r, we can have a particular term in the expansion. So if you put n equals to 0, what you are getting? You are getting nc0, a to the power n, and b to the power 0 will be there. So it is 1 actually. When you are getting n is equal to 1, you are taking the term nc1, a to the power n minus 1, b to the power 1. That means a to the power n minus 1 b. In this way, for various values of r, you are getting different terms here. So basically this expression is giving you the general form of the terms in the binomial expansion. So that's why this thing is called the general term. Sorry, general term of the binomial expansion. So I think this much is clear to everyone, and it is very convincing that this ncr, this combinatorial terms are coming as the coefficients, and why they are coming, I think this is clear from here. So if we consider all those values of r, all the different values of r, then we can write the whole expansion. So let us just once write the whole expansion like this. It's a plus b whole to the power n, and just we need to remember this general term, and varying the value of r, we can easily write all the terms. So see, the value of r is starting from 0 and ending at n. So let us just write it. So nc0, a to the power n minus 0, b to the power 0 means it is only a to the power n. Then it should be nc1, a to the power n minus 1, b to the power 1. Then it should be nc2, a to the power n minus 2, b square. In this way, if we come to the second last term, that means it is finishing with n. So the second last term will be with n minus 1, r is equal to n minus 1. So we can write it here, nc n minus 1, a to the power 1, because a to the power n minus 1, that will give you 1. And since I don't have that much space here, so I'm writing it like this, b to the power n minus 1. And finally we'll be having the term ncn b to the power n for r is equal to n. So this is the whole expansion of a plus b whole to the power n for any positive integer n. Now you can see that it is becoming so large. So that's why in a compact form we can write it using the summation later. So we can write it like r is equal to 0 to n ncr a to the power n minus r b to the power r. So this we can consider as the general expansion of a plus b whole to the power n. Okay. Now one note you can take here, that the summation is starting from r is equals to 0 and finishing at r is equal to n. That means we can see how many terms are there in the expansion. So how many terms are there? See, it is starting from 0 to n. That means if we consider the terms 1 2 3 up to n, these are n terms here. And since we are starting from 0, basically we are having another term in the before 1. So basically we are having the sequence as starting from 0 to n, we are having actually n plus 1 terms. So let me just write it here. So basically in the expansion we are having n plus 1 terms, and it's starting from 0 and finishing at n. Now as I've already said, that this term ncr a to the power n minus r b to the power r, this is called the general term. And here we can see that like this. Usually what we do, we write the general term as tr plus 1, and this tr plus 1 we write as a to the ncr a to the power n minus r b to the power r. Now why this is tr plus 1, why it is not tr? The reason is that when you are talking about the first term, that is t1, or you can say it is term 1, you are getting the term nc0 a to the power n. That means this corresponds to the value r is equal to 0. When you are saying t2, that means it is nc1. See, the second term is nc1 here, a to the power n minus 1 b to the power 1. That means it is corresponding to r is equal to 1. That's why when you are taking the term tr plus 1, that will be corresponding to the general term ncr a to the power n minus r b to the power r. So what should be tr? tr should be ncr minus 1. 1 it is always 1 less than the index. That's why the index we are taking here as tr plus 1, and we are getting ncr here. So this is the reason we write the general term as tr plus 1, and the general term is ncr a to the power n minus r to the power r, where we are having some restriction on the value of r, that is 0 less or equals to r less or equal to n. Now this concept is very important in most of the problems here. We are going to use this general term here. Okay, so this is the basic thing. Now one thing, let us see, that is called the coefficients. Let us just see what are the coefficients of different binomial expansions. So we are taking a plus b whole to the power n, and here first we are taking n is equal to 0. So obviously a plus b whole to the power n means a plus b whole to the power 0 means it is 1. So corresponding to n equal to 0, we are having 1 here. Now let us see what is the case for n is equal to 1. In case of n is equal to 1, it is a plus b, and you can say that the coefficients are 1 and 1. So we are writing the coefficients like this in a triangular form. In the same way, when you are taking n is equal to 2, it is a plus b whole square, and we get the coefficients like 1, 2, then again 1. For n is equal to 3, this will be 1, 3, 3, 1. So you can see that these terms we are getting like this in some the triangle with 1, and each row is also 1 and getting from the sum of the previous two consecutive terms. So here you can see for n is equal to 1 we are getting 1 and 1, and from that by taking the sum of those two ones we are getting the coefficient 2 in the next line for n is equal to 2. So in the same way, from 1 plus 2 we are getting this 3 here, and from 2 plus 1 we are getting this 3 here. In the same way, for n is equal to 4, now we can just find that coefficients from this one only. So how we are finding? The starting and ending positions are 1, and the intermediate values we are getting by the sum of these terms. So 1 plus 3, this will be 4. 3 plus 3, this will be 6. 3 plus 1, this will be again 4. So in this way we are getting the term 44641. And if you can see that this value is basically 4C0, this is 4C1, this is 4C2, this is 4C3, 4C4. Mention each term, and this triangle we are getting here is called the Pascal's triangle. Pascal's triangle. Now, what we can say that in the early days we used to find we can find the higher power expansions from this Pascal triangle because we know how the terms are coming. So it is just the thing to find the coefficients, the binomial coefficients. Now if you know up to certain row of this triangle, then from the previous rows we can always find the next row, the upcoming row for this triangle. Okay, so that means if you know the coefficients of n is equal to 4, then you can, from that you can know the coefficients of n is equal to 5 also. And in an inductive way we can find the same thing for all the values of n. Okay, so from this we can easily get what are the coefficient, the binomial coefficients are what. Now Pascal's triangle is also given by the property of the combinatorial values, like this property that ncr minus 1 plus ncr is equals to n plus 1 cr. So basically this is the background story of this Pascal's triangle. This single relation gives this triangle. If you observe it in here, that if you take n is equal to 1, then basically this two values will be giving you 1c0 plus 1c1, which is nothing but 2c1 from this formula. And here in this triangle we are getting the thing. In the same way, if you are taking n is equal to 4, or if you are taking n is equal to 3, then you see in this triangle what is happening. You can easily see that it is happening 3c0 plus 3c1 is equals to 4c1. This is happening. That's why we are getting this 4. In the same way, in this triangle, it is going like 3c1 plus 3c2 is equal to 4c2. So from Pascal's triangle, we can do this easily. Okay. Okay. So next, let us come to the use of the general term. Mostly in most of the sums. So now let us come to the use of this general term here that we have done previously here. The TR plus 1 is equal to NCR a to the power n minus R b to the power R. So this we can use here in problems like finding some particular term in an expansion, or finding the coefficient of some particular power of x in the expansion. In this way we can use this general term for various type of sums. Like in some of the problems we are getting we need to find the term which is independent of x. So that also we can do from this. Also, which is a very important topic here, that is the finding the middle term of the expansion. So for that also we are going to use this general term. So let us see one by one. Suppose we are given some expression like this, 3x minus say 4 by 5x to the power say 9. In this expansion, suppose we need to find the coefficient of say x to the power 6. Now I'm completely giving this by my own, it is not from any exercise, so I don't know whether the answer will come correctly or not. So let us just check. So what we need to do, we need to first write the general term tr plus 1. Clearly you can see here an is 9, this term here 3x is a, and this minus 4 by 5x is b. So for tr plus 1, what we can write, it's ncr a to the power n minus r, that means 3x to the power 9 minus r. Sorry, again I've written wrong, this n here should be 9. So we can write 9cr 3x to the power 9 minus r minus 4 by 5x to the power r. Now what we have to do here, we have to get all the terms of x in one place. So we can write it like this, ncr 3 to the power 9 minus r and minus 4 by 5 to the power r, and then we are writing all the powers of x, like x to the power 9 minus r is okay, then it is 1 by x to the power r here, that means you can say it is x to the power minus r. So ultimately when we are getting it, we are getting it like ncr 3 to the power 9 minus r minus 4 by 5 to the power r, and then it is x to the power 9 minus 2r. Okay, so this is the thing. So every term in the expansion of this thing will be looking like this, ncr 3 to the power n minus 9 minus r minus 4 by 5 to the power r into x to the power 9 minus 2r. Now what we are finding, we are finding the coefficient of x to the power 6. So basically we need to plug in this value here in the power. So for x to the power 6, what we can do, we can compare the value 9 minus 2r, the power of x, with 6 here. So what we can see from here, that 2r is equals to 9 minus 6, that means 3, and so r is becoming 3 by 2. So there is a clear indication that it is not possible, because r, we have already seen that r is a positive integer and it cannot be 3 by 2. So what will be the conclusion of this thing? We can say that since r is becoming a rational fraction value, that means the term x to the power 6 is not present in the expansion of this thing. So the conclusion is that x to the power x is not present of is nothing but 0. So suppose instead of x to the power 6, if we are finding the coefficient of x to the power 5, then we will be getting some value of r as an integer. So you just see here, instead of being 6, if we are finding the coefficient of x to the power 5, then we will be taking this one here. So we are getting r is equal to 2 from here. That means by putting it here, you can say that the third term will be carrying the term x to the power 5, and there by putting r is equal to 2 in this coefficient here in front, by putting r is equal to 2 in this expression in this bracket, we will be getting the coefficient of the term x to the power 5. So in this way we can find some particular term or the coefficients of some particular term in the expansion. Okay, so let us come to the next type. Say we are taking the same the type of problem, that is the term independent of x. So suppose we are taking this 3 by 2x minus 4 by 5 4 by 5x to the power 10 and we are finding the term which is independent of x. So how we can find it? So term independent of x means the term will be having the power of x to be 0, because we know that x to the power 0 is equal to 1. So that means the term will be carrying no expression of x. That means it is independent of x. So what we need to do, we need to write the general term, and from that we need to just make the power of x to be 0. Okay, so this thing we need to do here. So let us see. So we are writing the general term here. So it is 3 by 2, sorry, first we are writing the combinatorial term, that is 10 CR 3 by 2x whole to the power 10 minus r and minus 4 by 5x whole to the power r. This is the general term. Now let us just simplify it. So it's 10 CR 3 by 2 whole to the power 10 minus r. Then it is minus 4 by 5 to the power r. And then it is x to the power 10 minus r. And here it is x to the power minus r because x is in the denominator. So we can say it is x to the power minus r here. So ultimately we are getting 10 CR 3 by 2 to the power 10 minus r and minus 4 by 5 to the power r and x to the power 10 minus 2r. So obviously for term independent of x, what we need to do, the power of x should be 0. That means 10 minus 2r should be equals to 0. So clearly r should be 5. Now the term we can write like this, just you put r is equal to 5 here in this expression. So we can say that the term independent of x can be written as 10c5 3 by 2 to the power 5. This is 2. And it is minus 4 by 5 to the power again 5, because 10 minus 5 is 5 and this one also is 5. And the power of x will become 0, so it will be 1. So after simplification of this term, we are getting the term independent of x in this expansion. Now this calculation can be done easily by using calculator. So I'm leaving it here. You can do the rest. I think this much is clear to everyone. So let us now come to the next thing. That is the middle term of the expansion. So we are considering the expression a plus b whole to the power n, and from this we are finding the middle term of the expansion. So how we can come to the middle term? Now for this we are using some basic idea of medians, because median corresponds to the middle term. So here we are having these terms nc0 a to the power n plus nc1 a to the power n minus 1 b plus nc2 a to the power n minus 2 b square, and so on. In this succession, we are having the terms ncn minus 1 a b to the power n minus 1 plus finally it's ncn b to the power n. Now, suppose we are trying to find the middle term of the expansion. So how many terms are there? In total, we are having n plus 1 terms. Now just let us come to the idea of medians. What is a median? Suppose we are having the data 1 to up to n. Then median corresponds to the middlemost data in this succession. And if you are having n number of data, that means there will be two cases. Case one is that n is equals to odd. And in case of odd value, we are having the median as, let me call this median as m. Then we can say that the value of m should be the n plus 1 by 2th data in this succession. So if you are having the values 1, 2, 3 dot up to n, you are having the middle data at this data, that n plus 1 by 2th data will be your middle data. In the same way, for case 2, if you are having the same number of data, a 1, 2, 3 dot up to n, where n is becoming even now, then what we do, we take, there will be two middle terms actually. So we take the average of those two middle terms. This two data divided by 2. Then this becomes the median of the data. Now we are going to use the same idea here also. We are having n plus 1 terms here in the expansion, and we are trying to find the middle term. So obviously, for the middle term, we are going to use two cases, that n plus the number of terms here is odd or the number of terms is even. So if there are total n plus 1 terms, first case 1, we are going to use the idea that n plus 1 is odd. That means there will be only one middle term, and that middle term should be the term. So the middle term should be the term n plus 1, this is the number of data, plus 1 divided by 2, this much. So this term will be the middle term of the expansion, or we can say it like t n plus 2 by 2, or also we can say it like t n by 2 plus 1. And as we know how to expand the general, how to write the general term, we can write here t n by 2 plus 1 is basically n c n by 2, then a to the power, let me just remove the bracket, a to the power n minus n by 2, b to the power n by 2. So this will become the middle term when the number of terms are becoming odd. And when this will become odd, since n plus 1 is being odd here, so we can just simply say n is even. So when we are getting an even power in the binomial expansion, then we are getting the middle term only once. That means only single middle term will be there, and that middle term will be the term n plus 2 by 2. That means n by 2 plus 1th term in the expansion will be the middle term. Also we are finding the expression for the middle term as this one, ncn by 2 a to the power n minus n by 2, and this also you can write in a simple form, ncn by 2 a to the power n by 2 b to the power n by 2. Okay. So I think this is very much clear. Now let us come to the case 2. So in case 2, we are again having the same kind of thing. Now we are saying that n plus 1 is even, and that means n will become odd. So there is an odd power in the expression. So whenever there is an odd power, we are getting even number of terms in the expansion. And obviously for even number of terms, there will be two middle terms here. So if we find the middle terms, just like the case of even number of data in medians, so we will be having two middle terms, and that we can find like this. So remember, in case of even number of data, the median was used to be n by 2th data plus n by plus 1th data, and the average of it. 2th plus n by 2 plus 1th divided. So we are doing the same thing. So basically, these terms by 2th and 2 plus 1th are the middle terms. And for the median, we are taking the average. But in case of medians, so in case of middle terms, we are just taking So in case of the middle terms, we are just taking those particular two terms here. So for n number of data, it was n by 2th data. So for n plus 1 number of data, the middle terms should be n, sorry. So the middle terms here should be n plus 1 by 2th data and n plus 1 by 2th plus 1 this data. Or you can say these terms will be the middle terms here. So Tn plus 1 by 2, this one we can write like this, Nc n plus 1 by 2 minus 1, because whatever index we are taking here, the value of r should be 1 less than that. So this we are having. So it should be a to the power n minus this r, that means n plus 1 by 2 plus 1, and then b to the, sorry, this is minus 1 here, and then it is b to the power this thing n plus 1 by 2 minus 1. So if you simplify it, you can see that it is nc n minus 1 by 2, then it is a to the power, it's n minus 1 by 2, b to the power n minus 1 by 2. And after simplification, you can see that it is nc n minus 1 by 2, a to the power, it's n plus 1 by 2, b to the power n minus 1 by 2. And in the same way, when you are putting, we are finding the second middle term, that is nt n plus 1 by 2 plus 1. So obviously it should be nc n plus 1 by 2, a to the power n minus n plus 1 by 2, b to the power n plus 1 by 2. So after the simplification, you will be getting the thing like nc n plus 1 by 2, a to the power n minus 1 by 2, b to the power n plus 1 by 2. So as a compact expression for the two middle terms, we are getting the terms like this. And you can see there is a similarity or you can say that there is a symmetry in the terms. The first middle term is corresponding to r is equal to n minus 1 by 2, and the second middle term is corresponding to r is equals to n plus 1 by 2. Okay, so these are the two cases of middle terms. So whenever the expression is given for which we have to find the middle term, we can just come to the value of n, and from that we can decide which term should be the middle term, and using the idea of, so suppose we are finding the middle term for the previous expansion, like 3 to the 3 by 2 x minus 4 by 5x to the power 10. So n is even, that means the number of terms will be odd here. So we can easily find the middle term here. So here n is equals to 10, which is even. So the number of terms in the expansion we can write as 10 plus 1, that is 11, which is odd. And since the number of terms are odd, that means we can say that there will be only one middle term, and that middle term will be t11 plus 1 by 2. That is tn plus 1 by 2. So here you can say that it is t12 by 2, that means it's t6, and t6 we can easily write as 10c5 3 by 2 x whole to the power 5 and minus 4 by 5x to the power 5. So see how beautiful it is. Already we have found this term in a particular case here, this one. So basically the term independent of x and the middle term are both the same in this case. Now suppose instead of even power, let us have some odd power. So suppose we are doing the expansion for this one, x minus 1 by x to the power, say 9. So odd power means even number of terms. Number of terms is equals to 10, which is even. So that means there are two middle terms. So what should be the terms? We can say that the middle terms are, the first one is t 10 by 2, and the other one will be t 10 by 2 plus 1. So t 10 by 2 can be written as t5, and this one can be written as t6. So obviously always the middle terms should be consecutive terms in case of even number of terms in the expression. So you can see here the middle terms are t5 and t6. These are two consecutive terms. So when you are finding t5, it's very simple. 9c4 x to the power 9 minus 4, that means 5. Let us just write directly, and the next part will be this one, minus 1 by x whole to the power 4. In the same way, t6 can be written as 9c5 x to the power 9 minus 5, that is 4, and it is minus 1 by x to the power 5. So from these we can easily find, by simplifying and putting the values of NCR and NC5, sorry, NC4 and NC5, we can easily find the middle terms of the expansion. So very simple. These are the things. I think the concepts are clear to everyone. So hope you have enjoyed and understood everything in this video. In some next next video, we are going to solve some more problems on binomial theorem. So we are finishing it here. Have a nice day.